Okay, we're going to continue on with section 8.4. In 8.4, we have a lot more to do here, and it's a little bit more difficult because you have to know when things cancel out to give you 1 versus when things cancel out to give you -1. So let's go ahead and compare and contrast when things give you 1 versus when things give you -1. Okay, so 5 divided by 5 is 1. They're the same. A positive divided by positive is a positive 1. However, this is the same number, but I have one of them is opposite, so that cancels out to give me a -1. X divided by x is going to give me 1, but negative x divided by positive x is going to give me -1. Well, now let's apply that to expressions. This expression, the entire thing is exactly the same, so it cancels out to give me 1. This expression, I pulled out a -1, and now this is equal, but that negative remains, so that's going to be -1 there. However, look at this right here. If I were to factor out the -1, now it's the same, and you can clearly see that those cancel out to give you -1. Here's what I need your brain to understand. When they look exactly the same, but everything at the top has a different sign than everything at the bottom, it's going to cancel out to give you -1. But both terms must be opposite. If both terms are not opposite, then you can't cancel them out to get you -1. -x, positive x, -2, positive 2. So, what do I mean by that? An example. -x minus 5, positive x, positive 5. That gives you -1. -x plus 5, x plus 5. The x's are opposite, but the 5's are the same. Can't do anything with it. It's stuck just like that. Okay? Y minus 10, -y plus 10. The y's are opposite, the 10's are opposite, it's -1. How do you confirm that? Pull out a -1 and make them look the same, okay? So let's take that and let's do this example right here. So, how are these two fractions attached? These two fractions are attached by division, so we're going to do the keep, change, flip concept. So I'm going to go ahead and I'm going to keep the first one. I'm going to change the division to multiplication, and I flip the second fraction. From there, I'm going to write this as one fraction, putting parentheses around everything so that we understand that they're unique. Okay? So I'm going to drop down the 2 minus the x, and I'm going to factor the x squared minus 1 into two binomials. So that's x plus 1 and x minus 1. It is the difference of squares, okay? The denominator, I'm going to put this into two binomials, x plus 1 and x plus 1. Factors of 1 are 1 and 1. I need a positive to give me a 2. Go to the second one. You're going to put that into two binomials. That's x and x. I need a -10, so my signs are opposite. But I need a positive 3. So 5 is going to be positive and 2 is going to be negative. So at this point, every single thing is completely factored. Every single thing is completely factored. So we are going to do our domain restrictions. So if we do our domain restrictions, x plus 1 cannot be equal to 0, so x cannot be -1. X plus 1, we already have that, so it's x plus 5 cannot be 0, so x cannot be -5. And then x minus 2 cannot be 0, so x cannot be positive 2. So our restrictions are going to be x cannot be -1, -5, and positive 2. Okay? So we have our restrictions. Now, we are going to go from left to right and start canceling things out. Do I have a 2 minus x anywhere? I do not. Do I have an x plus 1? I do. Do I have an x minus 1? I do not. So what I have going on up here is going to be 2 minus x times x minus 1 all over x plus 1 times x plus 5 all over x minus 2. We're not done. I canceled out all the things that were exactly the same. Now we're going to compare and contrast the things that are very similar and check to see if they would cancel out to give you -1, meaning are both terms opposite signs. So I have a 2 minus x and an x minus 2. Positive 2, -2. Negative x, positive x. That says I can cancel this out and give myself a -1 there. Positive x minus 1, positive x. Those are both positive x, so I can't cancel that. So what I'm left with is a negative parenthesis x minus 1 all over x plus 1 times x plus 5. And that is as far as it can go. Okay? Next, I give you two formulas. I give you the sum of cubes and I give you the difference of cubes formula. These are formulas. You must memorize them. I'm going to have a cubed plus b cubed, and what that is going to be, you are literally going to take the cube root of a cubed and the cube root of b cubed. So that's going to be a and that's going to be b. That's what you're going to use in this formula right here. So I'm going to have the cube root of a is a, the cube root of b is b, and then I'm going to take the a square, I'm going to multiply them together and subtract it, and then I'm going to take the b and square it. Same thing here. So let's actually apply this formula. These two are perfect cubes. So I'm going to say, what is the cube root of 64x cubed? That is going to be a 4x. This is your a part in your formula. Then I'm going to take the cube root of 27. The cube root of 27 is going to be 3, and that's the b part of your formula. So the formula that you're applying up here is going to be a minus b times a squared plus ab plus b squared. Why? Because these are attached by subtraction. And when they're attached by subtraction, you are using this formula right here. Okay? So let's go ahead and write that down. 64x cubed minus 27 is going to be my a minus my b. A is 4x, b is 3. Then I'm going to take a and square it. A squared is 4x times 4x, which is 16x squared. And then I'm going to multiply them together to give me a plus 12x. And then I'm going to take the last term, which is b, and I'm going to square that to give me a 9. And that's going to be all over my denominator of 4x minus 3. When you apply this formula, this part right here is irreducible. I repeat, this part right here is irreducible. You cannot go any further with it, okay? So, with that being said, I want to find my domain restrictions. So my domain restrictions is 4x minus 3 cannot be 0. 4x cannot be 3, so x cannot be 3/4. And then from left to right, I'm going to cancel out what is exactly in common. 4x minus 3 is in common, and that's going to leave 16x squared plus 12x plus 9. And remember, when you apply the difference or the sum of cubes formula, the second trinomial that you use for the formula is irreducible. So I cannot go any further than that. Okay? Example. Here we go. How are these two fractions connected? They're connected by division. So I'm going to do the keep the first fraction, change it to multiplication, and flip the second fraction. And then I'm going to marry them by simply putting them together. Okay? So now we are going to factor the numerator completely. If I factor the numerator into two binomials, factors of 4 that will add to give me 5 are going to be 1 and 4. Do I have a GCF here? The answer to that is yes. What's in common is going to be a 2x in both of those terms. So if I pull a 2x out of 2x squared, I'm left with an x. If I pull a 2x out of the 6x, I'm going to be left with a minus 3. All over. Factor this into two binomials. That's going to give me an x and an x. Factors of 12 that are going to give me 1. How about a plus 4 and a minus 3? Wrote the wrong number there. Okay, over here, this is the difference of squares formula, so that's going to be x plus 1, x minus 1. So everything is completely factored, so now I need to do my domain restrictions. My domain restrictions are going to come from x plus 4 cannot be 0, so x cannot be negative 4. X minus 3 cannot be 0, so x cannot be positive 3. X plus 1 cannot be 0, so x cannot be negative 1. And x minus 1 cannot be 0, so x cannot be positive 1. So those are your restrictions. So x cannot be negative 4, 3, negative 1, and 1. Okay. From left to right, we're going to start canceling out. Do I have an x plus 4 up top and bottom? Yes, I do. Do I have an x plus 1? Yes, I do. Do I have a 2 or a multiple of 2 or an x or a multiple of x? I do not. Do I have an x minus 3? I do. So what is left on top is 2x, and what is left on the bottom is x minus 1. And that is done. Last example. Very nice. They're already attached by multiplication, so I can go straight into factoring into two binomials. So that's x plus 3 and x minus 2, because those are the factors of 6 that are going to give me a plus 1. Times, I can put this into two binomials, x plus 5 times x minus 5. On the bottom, I'm just going to keep that as an x minus 5. And the trinomial is going to turn into two binomials of x plus 3 and x plus 1, because that's going to give you a 4. From there, I'm going to do my domain restrictions. So x minus 5 cannot be 0, so x cannot be 5. X plus 3 cannot be 0, so x cannot be negative 3. And x plus 1 cannot be 0, so x cannot be negative 1. So x cannot be 5, negative 3, or negative 1. So from left to right, we're going to start canceling. Do I have an x plus 3 in the denominator? I do. Do I have an x minus 2? No. Do I have an x plus 5? No. Do I have an x minus 5? Yes. So what remains is going to be x minus 2 times x plus 5 all over an x plus 1. And that is completely done then. Tonight's homework is 8.5 worksheet 2.